Hi, I'm Luisa, Product Manager for ultrafast fiber lasers at TOPTICA. If you work with two-photon microscopes, chances are you also have a titanium sapphire laser somewhere in the lab. And if you do so, you probably recognize the sound of the chiller even before you enter the room. Traditional two-photon microscopy setups often rely on titanium sapphire lasers or OPOs. They are incredibly powerful tools, but they are also not exactly small. Once the laser, the chiller and all the supporting hardware are in place, you suddenly realize that a large part of your optical table is already taken. And if you want to add just one more component to the experiment, it often turns into a bit of a puzzle. That's why we built the FemtoFiber Ultra based on robust fiber laser technology. It comes in a compact shoebox-sized design with all the features you need inside. No chiller, no noisy cooling system and no need to sacrifice half of your optical table. You can mount it on the table or, even vertically, on a wall if space is precious. It's quiet, efficient and surprisingly low maintenance. In other words, concentrate on your experiment, not on your laser. Then there's the classic microscopy dilemma. Your images could be brighter, so you increase the laser power. The images improve, great! But now you start wondering whether your sample is still enjoying the experience. Instead of just throwing more power at the problem, we focus on pulse quality. Our FemtoFiber Ultra uses clean pulse technology. It produces pulses that are very short and that are pedestal-free. In practical terms, almost all the laser energy sits exactly in the main pulse, where it actually contributes to two-photon excitation. That means brighter fluorescent signals and better contrast without needing excessive power at the sample. So your images improve, while your sample remains much happier. Two-photon microscopy is already complicated enough. Your laser should make your life easier. With compact fiber laser technology and clean, ultra-fast pulses, our systems make high-quality imaging simpler and more reliable. And if you'd like to see how it works, let's talk.